This video lecture is all about visual derivatives, meaning we're going to think about derivatives graphically and the relationship between f, the original function, and f prime, the derivative. So how can we relate the derivative to the function? So here I have a function that is graphed, and I have its derivative graphed. So you should go ahead and copy down this curve and copy down this derivative. And we're going to relate different sections of each graph to each other. So here we have a portion of the function where the function is decreasing as we move left to right. The curve is going down. So the slope is always negative in this red section, which corresponds with this section of the derivative where the derivative is negative. So we have a negative slope. Negative slope corresponds with negative outputs. So you can see here, like the slope here is -5, and then -4, -3, -2, -1, and then we're approaching a slope of 0. Okay, the slope is negative this whole time because the function is decreasing. Okay, right here the tangent line is flat. The slope is equal to 0, and then the function starts to increase, and the derivative starts to be positive. So now we have a positive slope. The function is increasing. Positive slope, and then positive outputs for the derivative. Okay? So this full picture that I have here is going to be an important one for you to copy down, and it's especially helpful if you have some colors to color code. So highly recommend you pause this video and get this picture down. And then I'm going to give you another one. So here we have the function, and here we have the derivative f prime. So we're going to break this down again section by section. If you really wanted to, you could try to do this by yourself, but I'm just going to go ahead and do this now. So we have the function is increasing. Right, it has a positive slope, it's increasing, it's increasing. The derivative has positive outputs, right? Okay, we have a positive output. We have an output of 15, and then 10, and then 5. Okay, all of these outputs are positive until here when we hit 0, where the function is flat, right? It's at a max. It's a flat slope. And then the function starts to decrease, so the derivative is negative in the whole section where the function is decreasing. The function is decreasing. The derivative has negative outputs. Finally, the function starts to increase again, and the derivative has positive outputs. So wherever the function is increasing, the derivative must have positive outputs. Wherever the function is decreasing, the derivative must have negative outputs. Again, highly recommend you get this full picture down before moving on. And now we are going to sketch a derivative given a function. So if I have a curve that looks something like this, okay, and I want to sketch the derivative of this function, first thing I need to do is recognize everywhere where the derivative will be 0. Okay, derivative is 0 when curve is flat. So where is the curve flat? Well, it's flat right here. And by flat, I mean it has a flat tangent line. If I were to draw this tangent line right here, it would be a tangent line with a slope of 0. It is flat. And that happens at all of these bumps, the maxes and the mins, where we have these flat slopes. So I'm just going to go ahead and put an x-intercept wherever the slope is flat. So I have one right there, right there, right there. Okay, there's another flat part, there's another flat part. Oops. My hand got in the way there. Okay, so another flat part. Okay, next we need to determine, does the derivative start negative or the derivative start positive? Well, let's look at the curve. The curve starts by decreasing, so the derivative has a negative output. So we must start down. And then we're just going to loop our way through the x-intercepts. So the derivative is negative, the function is decreasing. Now the function's increasing, so the derivative is positive. Okay, now the function is decreasing, so the derivative is negative. Okay, Okay, the function's increasing again, so the derivative's positive. Function's decreasing again, so now the derivative's negative, and then now the function's increasing, so the derivative's positive. So this red represents the derivative of the green curve that we started with. Okay, let's do another one. So let's say we have a function that looks something like this. Okay, so again, we need to identify all the flat parts. So there's a flat part right there at that maximum, then another flat part, then another flat part. So now let's see, the function starts by increasing. See that? It's a positive slope. So the derivative has to start up in the positive area. So we have a positive output. The derivative is positive, so the function is increasing. Okay, now the function starts decreasing, so the derivative is negative. Boom. At this point, the function stops decreasing and then starts increasing again. So the derivative goes positive, the function's increasing, the function's still increasing, the function's still increasing, and then now we hit this point where the function starts decreasing. So now we're just going to let the derivative go down forever. Cool. Let's do another one. Let's say we have a function that looks something like this. So to draw the derivative, we have to identify all the parts where the function's flat, which only happens one time at that minimum. Okay, the function starts by decreasing, so the derivative has to start negative, and then it hits the point where it's flat, and then the derivative goes positive because the function starts to increase. Okay, so that straight line represents our derivative. Okay, what if we have a straight line? Oops, let's go back to green. What if we have a straight line? Okay, we'll just say it looks something like this. Okay, so how do we identify the slope of that? Well, it is a always positive slope, and the slope is never changing. So the derivative is just going to be one constant slope that is positive. It would look just something like this, like a horizontal line, because it's saying the slope is the same at every x value. What's the slope right here compared to the slope right here? Well, it's the same because this is just a straight line, right? So we can start to get even a little bit more complex with this, and I can draw my absolute value x function, which looks like this, right? So what happens? Well, this is a straight line with a negative slope, and then suddenly it switches to a straight line that has a positive slope. So if I draw the derivative, it's going to start by being a negative constant, and it's going to be negative that whole way out, and then it's going to suddenly go positive, right? And then I think, we'll say both of these are wholes, okay? All right, let's do another one. This next one you can try to do by yourself before checking your answer. Okay, let's just make it have a lot of flat parts, so we'll go. Okay, so go ahead and try to sketch this, and then when I resume, the derivative is going to magically appear, so you can check your answer. Here it is. The function starts by decreasing, so the derivative starts negative, and we approach that point where the slope suddenly becomes 0 because the function's flat. So we are now 0, and now the function's increasing, it's flat. It's decreasing, 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 it's flat, okay? It's increasing until here when it is flat again, decreasing until here when it's flat again, and then it increases forever after that, so the derivative goes positive. Okay, we're going to do one more, and this one's going to be a little bit of a weird one. Okay, so weird piecewise curve here. Notice there's not arrows on the end, so this is not a function that goes off to negative and positive infinity. It's just restricted to this interval. So first let's mark the flat parts. So we have a flat part right here. We have a flat part right here. But then the weird thing about this one is that we also have this whole segment right here where it's just a straight line, or a flat line, right? So that whole time the derivative has to be 0. So I'm going to draw along the axis there. Okay. So then the function starts by increasing, so the derivative must start positive, right? So we're going to have the derivative start positive. Okay, it hits this point where the function's flat, and then the function starts to decrease, 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 until right here, where suddenly the function starts to be flat. So we're going to jump from a negative slope up to a slope of 0, right? And that slope of 0 actually extends a little bit further to there. And then what happens? Suddenly, the function starts to have a positive constant slope. So we have to have our derivative jump up and be a positive constant. So we're just going to come up here and say, let's say that slope is just like something like this, right? Okay, and then suddenly the function starts to decrease, so the derivative has to suddenly become negative. So we're going to jump down and make the derivative negative. Negative, 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 negative. Okay, let me try to redo that so I can hit this line a little better. Okay, it's negative, it's flat, and then it's positive up until there. Okay, so that was a weird, wonky one, just to make this a little bit harder. But most examples will look like the easier ones that we did at first. Okay, that's it.